Question 7. Human beings are electrically neutral objects to a high degree of accuracy. In this question, you will estimate the force that would exist between two students standing 1 meter apart if they had just 1% of the electrons in their body somehow removed, leaving them both positively charged. Take the mass of each student to be 60 kilograms, and as a rough estimate, assume that humans are 100% water. The molecular mass of H2O, that's the mass of 1 mole of molecules, is 18 grams. Calculate the number of water molecules that each student contains. So we want to know the number of moles and then divide it by Avogadro's number. So the number of moles will equal the mass over the molar mass. So their mass is 60 kilograms. We're going to put the units in to make sure we don't make a mistake. The molar mass is 18 grams, but because we're in physics, we're going to write this down as 0.018 kilograms. So that's the number of moles. Then the number of atoms should just equal the number of moles times Avogadro's number. So 60 over 0.018 times 6.02 times 10 to the 23. Sorry, that's a bit messy. 6.02 times 10 to the 23. That comes out as 2 times 10 to the 27 molecules. Sorry, yeah, molecules. Find the number of electrons in a water molecule. So there's 2 hydrogens, which gives us 2 electrons, and there is 1 oxygen, which gives us 8 electrons. So in total that's 10 electrons. Find the total number of electrons in each student. Well, we know they've got this many molecules and each molecule has 10 electrons, so the total number is just 10 times that, so 2.0 times 10 to the 28 electrons. Taking 1% of these away will leave each student with a net positive charge equal to the charge of 1% of their electrons. Find this charge. So the charge is equal to the number of electrons multiplied by the charge on 1 electron, which has a symbol E. So 1% of this is 2.0 times 10 to the 26 multiplied by the charge on 1 electron is 1.6 times 10 to the minus 19, which gives us 32 million or mega coulombs. So a huge amount of charge just for 1% of the electrons. This is positive, but it says that in the question, doesn't it? But we could put positive in here just to highlight that. Calculate the force between the two students if they're standing 1 meter apart. So their force Q1, Q2 over 4 pi epsilon naught r squared. So this is 32 times 10 to the 6. That's the charge on one of them. The charge on the other one is the same, so we can square the 32 times 10 to the 6 over 4 pi times 8.85 times 10 to the minus 12. Distance between them is 1 meter, so times 1 squared. That gives us a force of 9.3 times 10 to the 24 newtons. Comment on the size of this force. Well, we could say it's big. How big? Well, we don't have many things with forces on that large. If we were, trying to come up with something big, then, we might say what would be that order of magnitude. Well, when you see times 10 to the 24, you might remember that the mass of the Earth is 6 times 10 to the 24 kilograms. So 9.3 times 10 to the 24 kilograms is quite close to being it's a bit of a silly comparison because obviously this is in kilograms, so then we have to sort of turn this into a force. Well, the way that we normally do that for mass is to talk about the weight. So effectively what I'm saying is if you put the mass of the Earth as an object on the surface of the Earth, so it's in the Earth's gravitational field, it would have a weight that's slightly larger than this, but not ridiculously larger than this. It was about 6 times. So 9.3 is about 1/6 of the weight of the Earth, and then slightly strangely on Earth. I'm not sure that makes it easier to imagine, but it does at least give us a sense that it's a big number.